jump into our next question, which is balanced binary tree. Let's see what this holds for us. We are given a binary tree, and obviously we need to check if it's a balanced binary tree or not. And how do we check if it's a balanced binary tree? If the absolute difference of its right subtree and the left subtree is less than 1, or 1 equal to 1, then we say it's a balanced binary tree. For this it's 0 0 for them. For it's 1, because it's 0 0, height of this is also 0. It's balanced. This tree is balanced. For this it's a single node, so obviously it's balanced. For this height is 0 1 2. I mean, just consider this for 1 and 0, so it is -1. So 0 minus 1 equals to -1. So this is also balanced. This clearly is not balanced, and if it's empty, it's balanced. Let's write something. First, let's write a code which we will be accessing quite a lot, which is we need to calculate the height. Private HEIGST height. What will it return? Let's return a int HEI, not HIE. Okay, and then let's give it a tree node, and it would be a root node. Let's call it a node. Okay, now what we want to do is we want to return 0 if it's a null node. So if root, if node equals to null, return 0. TURNZERO. And then if it's not if it's not null, what we want to return is return maths.max of either the right or the left, so whichever is greatest. Node dot left comma node dot right, height of whatever is greatest, and to that we want to return +1 there. So this will be done. So this will calculate the height. Now here how can we say if a tree is balanced or not? If root equals to null, I mean if it's empty, obviously it's balanced, so return true. Not empty, I mean if it's not pointing to anywhere else, it's kind of empty. Then what we need to do is then we need to calculate int left, and left equals to height of left. If it's not empty, it has a left child, so root dot left there. And let's also check for int right. Again the same argument, if it's not empty, it has a right child. Root dot right. Now what we want to do is, if the absolute value of this is greater than -1 and less than 1, so what we'll do is we'll create an integer called, let's call it h, equals to right minus left. Done. Now we need to check if h is greater than 1 or if h is less than -1. If any of these condition is true, we need to return false, because if at any point this happens, then it's false. Else what we need to return is we need to return we need to call this function is balanced on on the right as well as on the left. So return is balanced on tree node dot root dot right. First call it right, then copy this thing again, copy paste, and this would be left. And we need to check if both of them are true or not a single one, but both of them should be true. Done. and done. I believe this should work fine if I haven't like misspelled anything or called any wrong function there. Yeah, it works fine for this. Let's check it for the complete solution. If it works fine, it works fine. And it was a really simple problem, a really basic one. And thank you guys for watching this.